Using Simpsons rule with three ordinates, the integral of 2x dx from 0 to 2 is equals to a 13 on 3, b 13, c 3, d 4. Let's find out which of these options is correct. That is the integral, let's say from a to b of f of x dx is equals to h over 3 into y0 plus yn plus 4 into y1 plus y3 plus many others. Again, plus 2 into y2 plus many others. This formula can still be summarized as the integral from a to b f of x dx is equals to h on 3 into first plus last plus 4 odds plus 2 evens. So this formula and this one are the same thing. Now let's see how this formula can be applied to solve this problem. Here we need to know the value of h. We need to know what is y0, what is yn, and so on. And to do this, the first thing is to know the value of h. H here is called the step length or the step height. And when the limits of the integral are given as a and b, h is calculated from the formula b minus a all over n. This n here is obtained from the formula k minus 1. This k here is the number of ordinates, that is the number of y values given in the equation, and there are 3 ordinates. So it means that here I'll have 3 minus 1, which is equals to 2. So n is 2. Now from the equation, the integral is from 0 to 2. That is, comparing the integral with this formula, it means the value of b is 2, that is 2, minus the value of a is 0, that is 2 minus 0, all over n, which is 2. So it means h is equals to 2 minus 0, which is 2 over 2, and this is equals to 1, that is h is 1. Now I need to get y0, yn, y1, y3, and so on. To do this, I will come out with a table. That is a table like this. These are the x values and these are the y values. That's yn is the y values with their corresponding value of n. So when n is 0, we have y0. When n is 1, is y1. N is 2, the ordinate is y2. Now let us calculate the x values corresponding to this ordinate. From this integral, f of x is 2 to the power x. That's comparing this to the general formula. That means f of x is equals to 2 to the power x. I know here y is taken to be f of x, so it means that y is equals to 2 to the power x. You know, this integral is carried from x equals to 0 to x equals to 2. So it means the first value of x here, that is x0, is equals to 0. And the last value of x, that is x2, the corresponding x value to y2, is x2 equals to 2. So the first value of x is first limit of this integral, and the last value of x, which is x2, is equals to the last limit of this integral, and that is 2. Now it means that here, which is x0, the value is 0. Now here, which is x2 corresponding to y2, the value is, you know, the formula to get any x value along the x axis using the step length is xn plus 1 is equals to xn plus h. That's to get the next x value, I add h. So the corresponding x value here is x1. So from this formula, to get x1, I will take x0 plus h. That is the same like x0 plus 1, since h is 1 and x0 is 0. So it means I'll have 0 plus 1, which is 1. So it means that x1 is 1. So here I'll write 1. Now I've obtained the x values. I need to obtain the y values. You know, y equals to 2 to the x. Here the corresponding y value is equals to 2 to the power 0. That is y0 is equals to 2 to the power 0, since the x value here is 0. So in the place of x, I put 0, and 2 to the power 0 is 1. So it means that here I'll write 1. y1 is equals to 2 to the power 1. That's the value of x here is 1. So in the place of x, I put 1, and 2 to the power 1 is 2. So it means that here I'll write 2. Now the value of y2 is equals to 2 to the power 2, since the value of x2 is 2. So in the place of x, I put 2. 2 to the power 2 is 2 times 2, which is 4. So here is 4. Now the next step is to calculate or to approximate this integral. The formula says I should write h over 3. H is 1, and then here I will have 1 over 3 into y0 plus yn. y0, as I said, is the first value of y here, which is 1. So it means that I'll have 1 plus the last y value, which is 4. That is first plus last, plus 4 into odd. The odd y value here is y1. y1 is odd because the subscript here is an odd number. 1 is an odd number, and this is the only y value that is odd, and the value is 2. Now normally the formula says now I should take plus 2 evens, that's plus the sum of even numbers. The even y value here is this, that's y2. I cannot use it again because I've already used y2 as the last value. So here I'm using the value one time. I've already used y2 in the place of the last value, so I cannot use it again. And then this sum will remain like this. That is 4 times 2 is 8. 1 plus 4 is 5. That is 5 plus 8 all into 1/3. 5 plus 8 is 13, and 13 times 1/3 is 13 over 3. So it means the correct approximation to this integral is this, which is option A.